Hi there, I'm Hao, and this is just another video of me solving random bit code problem. So let's begin. Um, okay. So seats reservation manager. Okay, design a system that manage the reservation stay of n seats that are numbered from 1 to n. Implement the seat manager class with the constructor initialize the seat manager object that will manage n seat from 1 to n, and then all seats are initially available. Okay. Reserve, fetch the smallest number of unreserved seat. Okay, reserve it and return its number. Sure, and we have unreserved, right? We just put the seat number back into our list. Okay. Um. Yep. Let's look at the constraints. We know that n will be at least one. We don't have to worry about the edge case here. Our seat number will be from 1 to n. And then every call to reserve, it will guarantee there will be at least one unreserved seat, right? So this is one less edge case to worry about. And then each call to unreserved is guaranteed that the seat number will be reserved, right? So you don't have to worry about that. Okay, so let's look at the example here to see what they meant. So initially we will have 5 seats from 1 to n. So we're gonna have like 1, 2, 3, 4, and 5 right here. And then they want to reserve. Right, so whenever we reserve, we want to fetch the smallest number, right, of the unreserved seat, which is 1 here, right? So we need to take it out, and then we reserve again. This next model is 2, right? So we return 2, and we unreserve 2, so we put 2 back, right? So 2, 3, 4, 5. We reserve 4 times in a row, right? So we have yeah, we yes, we reserve. The first time is 2, the next time is 3, the next one is 4, right? And the last one is 5, right? 4 times in a row. Right. So now we have an empty list. There's no available seat left, right? But the last one, we reserve seat number 5 here, right? So we put 5 back, right? So which is our end results here. So how do we always reserve a minimum seat, right? So I think we can use a heap to solve this, a min heap, right? So every time we pop something from the root, it will just be the smallest one, right? And when we add something to the heap, it is guaranteed that the root will always be the smallest value, right? I'm not gonna go through how to build a heap here. I'm just gonna use a heap that we already have. Just if you use Java, Python, just feel free to use the built-in one, which is really straightforward here. So we want to build a heap, right? So let's say this dot six equal to new min heap, right? And we want to heapify it from 1 to n. So 0, want to push it from 1 to n. 1 I less than equal to n. Plus plus. And for each number, let's call this one seed number. Yeah. So we want to this dot seed dot push seed number, right? And when we reserve, what do we want to do? We want to return the smallest number of the unreserved seat, right? Reserve it and return the number. Okay, so we can just go ahead and return the element from the root, right? And pop it off, of course, to reserve. That pull, and then unreserved. So we can just add it back, right? So this dot push the seed number back into our list, our heap, and that's pretty much it. Run, accept, submit, and it worked, right? So the spike complexity here would be O of n. The time for the construction would be n log n, right? Because we need to iterate to n time, and then when we add something, uh, heapify up, right? So that is log of n, so n log n general, right? When we pull something, when we remove something from the heap, that is log of n, right? We just swap it and heapifying up. Same for when we add something to the heap, also log of n. Okay, so thank you for watching.